Okay, so guys, with that basic understanding, we can see we are expected to download the log file, look at the password. So I've downloaded it. The name of the file is called PrintNightmare, is a zip file, right? So you can see, I'm just going to cancel this because I already have the file. So so once that is downloaded, you can see we are also told that we can use the red line for investigation. So there are some tools that we are going to be using for investigation, guys. So one of them is the red line. You can see red line is a tool from FireEye. So it's basically used for memory and file-based analysis, also for IC analysis. So we are going to install some of these tools and we are going to upload the log files on them and start analyzing. The other tool we are going to be using is called Brim. So Brim is more like Wireshark, but it's more efficient than Wireshark when it comes to analyzing large pickup files. So, and the good thing is that it is also integrated directly with Wireshark. So you can use Brim and use Wireshark. So I have downloaded these tools. So I'm just going to take you guys to my lab. Okay, so guys, these are the tools. You can see we have the red line. We also have, this is the log file. So you can see we have a pickup file, and also we have a mediant analysis file. So the mediant analysis file will be uploaded on the red line, so the red line too, while the pickup file will be uploaded on the Brim, guys. So I'm just going to, so before we go on, we can also see we have a simple guide to show us how to install the Brim. Look at the guide. You can just go on and follow the link on to download and install the Brim, guys. So it's just a very simple tool and very simple step to download. So once we've downloaded and installed the Brim and also the red line, you can see I also installed Wireshark. Yeah, it's also important. So let's go on with the challenge. Okay, so guys. Okay, so guys, you can see, so we have several questions to answer. The first is like looking through the alerts, in the Brim, what is the vulnerability name and its corresponding CVE, right? So the question is, what is the vulnerability name for the PrintNightmare vulnerability and its corresponding CV, looking through the file that we downloaded. So I'm just going to show you guys. Okay, so guys, this is the Brim, right? So what I did was to go through to upload the file, to upload the challenge file. When I did this, that's why you can see I already uploaded it. So this is the file, the challenge file. So guys, so once you upload the pickup file, you can see it's going to load up and bring up the logs, as we can see on the screen. So these are the logs that we have from the pickup file. So from this log, we'll be carrying out several analyses, right? So like I said, to double confirm our checks, and our analysis, we are going to be using more than one tool. So this is the Brim. So I'm just also going to, so this is also the red line. So to upload that file, all we need to do is click, then you can open a save analysis, right, guys? Then once that is done, you can, like I said, the mediant analysis file, you just pick it and open it. That's very simple. So let's go on to start answering the question. So like I said, the first question that was asked was, what is the vulnerability name and the corresponding CV. You can also take a look at the hints. Okay, so we are told that this is how we are going to respond, right? So let's go back to our print. So guys, don't forget, we just finished analyzing this, what's it called? The workflow. We finished talking about the workflow, the attack vector of the principal, the PrintNightmare vulnerability. So like I said, the first thing you will see is that when the request call function is initiated, event is actually generated because there's an ROPC call connection to the victim machine. So, and also when the victim machine copies the malicious file, as you can see from the attacker's assembly share, to its own spooler driver. So events, because it's a new file or it's a new process, so events are generated. So the first thing we are going to look out for, it says, so I'm going to run a query to look for ROPC add printer driver, because that is where it's starting from. So because we have several logs, so I'm just going to do a filter to look out for RPC printer driver. Okay, so we don't have any data, so I'm just going to make sure that we are able to capture all the events. So I'm going to click on hold. So RPC printer driver. Okay, so let's see if we're getting that correctly. Okay. So I'm just going to release that so that we can see all the okay, back. You can see, guys, all the logs, and take a look at some of the alerts or events. So guys, we have several data we have several categories of data here. So I'm just going to clear this off so we can so guys, this is the log again. So I'm just going to research for an ROPC, right? Add printer driver. So like I said, this is a function call that exists within the print spooler service. It is used to add printer driver, remotely to a printer service. So the PrintNightmare vulnerability leverage on this call function. That's what I'm searching for it throughout my log file. So as you can see, guys, we have about 3 alerts that contains the the RPC add printer driver, keyword. So let's take a look at, so we can see this is our timestamp, this event type. You can see the source IP address, guys, the source port. So the attack is coming from this 10.4. You can see the destination. If you take a look at the call function, you can see that it is the attacker that is actually sending the ROPC, what's it called, add printer call function, so this is the source and this is destination. So guys, if we go back to our log, we can see that here we have the source IP address, we have the destination IP address. So this request is done on port 445, like So of course, it's leveraging a TCP protocol via SMB, right? You can see, like I said, the malicious file is hosted on an SMB share. So definitely it's going to leverage on port 445. Yeah, so let's take a look at the last signature. You can see it's showing us there's a possibility of this is the CV, and also this is a PrintNightmare. So it's telling us that there's a possibility for uh, PrintNightmare. You can see exploits. This is the spooler service, and also this is the call function. So to answer that question, what we need to do is so I think there's a basic format. So we need to copy out. So it's just taking a little bit time to load. Yeah. Also, I would like to bring to our notice that we also have several related alerts, that's related to these particular events, right? So if we do an increase, you can see, guys. So guys, you can see uh, showing us the connection stream. You can see the originator from .4, and we can see the responder. So there's actually a TCP connection, complete connection request and response, sync arc and acknowledgement was done between the source IP and the destination, right? Then you can see that data was sent and an acknowledgement, right? Right. So from here, we're able to get some data. We can also open this file within Wireshark. You can decide to open it to also view from the Wireshark, right? Events from the Wireshark. So guys, to answer the first question, you guys can see, just a minute. Okay, we are able to see from the alert signature, right? Just trying. Okay. Okay, guys. So you can see from the alert signature, you can see that we have the CV. So I'm just going to copy this out, and going to put it on a notepad. Make this a little bit bold. So I'm going to copy this out. So guys, you can see, and we have a format from the question saying it should be in this format, guys. So we're going to should be vulnerability name. So we're going to vulnerability name slash the CV. So this is the vulnerability name. We're going to put it this way. Think open brace and close brace. We have the vulnerability name, then also we have the CV. So guys, this is how, let's see. Can submit. Yeah, guys, so that was correct. So let's move on to the next question. So the next question is asking us, what is the attacker's IP address, guys? So what is the attacker IP address? We are going to take a look at the logs one more time. You can see we have a source IP address, like I said, from the attack workflow. So from the attack workflow, guys, the attacker initiates the ROPC add printer driver, so this is to add what's it called, like I said, to add a driver to the print spooler service, right? So it's that request is always coming from the attacker. So if we take a look at, this is source IP address and this is destination. So my guess, my hypothesis, sorry, will be going for .4. And let us take a look at what we have on the red line. So if we take a look at the red line, for example, I want to go on to look at if we can see on the let's see within file system. So within file system, for example, okay, there's I'm just going to take a look at what we have under the port session. Let us see establish, because from what we have from the, what's it called, from Brim, we're able to note that there was actually a connection established between the .4 and .2. So what we're going to do now is that under the port section on the red line, this is the red line. So like I said, once you upload your log on the red line, it comes out with different data header event types that we can see, from system information to, you know, a whole lot the running processes that was discovered, you know, to ports, to ERP entries. So if we take a look at, for example, ERP entry, right? Let's take a look at what we have within the ERP entries. So we can see that we have a connection. We can see .4, right? You can see an ERP connection from .4. You can see, if you take a look at this, there's a connection between .2 and .4, guys, right? There's a connection between these two guys, the two IP addresses. Let's take a look at the port to see if we have any established connection. So, okay, so you guys can see we have several listening port, then also several unknown port. So I'm just trying to look out if we have, you can see we only have just one established connection. And if we take a look at those port, the IP address, you can see that it's between the .4 and a remote IP address .2 on you can see the remote port, the local ports, remote ports, the ITCP. So we can also see that that connection is coming from run.dll.esc. If we take a look at our attack vector diagram, you can see that when the run.dll32.esc executes the malicious DLL file, what happens is that it initiates a reverse shell connection back to the command and control. So this could just depict that the run.dll was established connection from the what's it called, from the local IP to the remote IP address, right? So this connection, there was a connection between the victim system and the attacker machine using from the run.dll 32 process, right? So if we take a look at, if we go back to our log, we can see that this is what happened. And this .4 is local IP and remote IP is on .2. Right. So guys, having said that, we can see that our, from the question that, what's it called, our IP address, take a look at it in, okay, yeah, so you can see they've given us different ways to get this done. So we've looked at Brim, Redline. We could also take a look at what we have on Wireshark, for example. So I'm just going to initiate that connection to say, okay, I'm going to close these guys. So if we go back to the Brim, so this is what we're going to do, guys. Just a minute for it to load up, okay? So let's create by alert. For example, you can see that we have several alerts. You can see the source IP address and the destination IP address. As we can choose to open this guy, you know, in Wireshark. So guys, just yeah, it's going to load up. Yeah, while that is loading up, so we can see that yeah. So uh, let's take a look at that file again. Okay, so like I said, we can click here to open up Wireshark. All right, so I want us to see the view on Wireshark too. So I'm just going to respond to that. The answer will be 10 dot 10 dot 10 dot 4. Right. Oh, sorry. Don't forget the format. Okay, it has to be in that format. 10 dot 10 dot 10 dot 4. Right. So this guy. Okay, let's take a look at it again. So we have Wireshark coming. Let's take a look at the file. Okay. Yeah. Okay. Okay, guys. So you can see that we have the source IP. Then we have the destination IP. Exploits. You can see that this is PrintNightmare. Okay, so from the source to the destination 10.10. Okay. Okay, guys. So this is for Wireshark. You can see that we have source IP.4 and destination.10 that establishes sync arc and acknowledgement, TCP connection request. Yeah. Right. So we can also see the information from these points too. So that's also how we can confirm. So the source, so the question again was asking us, what's the attacker's IP? The dots to okay, so the attacker's IP is .2. Okay, let's justify that. Let's go back and take a look at. Okay. Okay. I want us to take a look at what we have on the red line. We're able to discover that run DLL the2 established process was using the local port IP, right? It's running on this port IP. Sorry. So the process name, the process run DLL32.exe is running on this port, on this IP address, and establish a connection to a remote IP address, which is .2. And if we take a look at the attack vector architecture that we have, so the run DLL is actually on the victim system, and the remote system is the attacker machine. So of course, if we take a look at what we have on the remote IP address is .2. So we can see that because the run DLL is running on the local IP address, so which is the target machine, it is not on the what's it called, the attacker's machine, right? So the remote IP address is the attacker's machine, right? Okay, so guys, that means if we take a look at the question again, that means .2 is actually correct, which is the attacker's IP address. So the victim's IP address is .4, right? So let's go on to look at the next question. What is the attacker's share path? Okay, so you can see the format is to be on the I//IP/path. So the attacker share path, let's take a look at our log. So if we take a look at try and scroll down on the packets on the Wireshark, the attackers. So what I'm going to do is that we are going to filter based on IP, right? The IP.source src equals to shaper, that is 10.10.10.2, which is the attacker's IP address. You can see this is the attacker's IP address. We want to be able to view what we have. Sorry. Take a look at. Okay. Is log. So source. You can see create response file. This is the file that was created, the DLL file that was created, guys. So what I'm trying to look out for is to see if we have the path specified based on filtering for this attacker's IP address, because the question we are being asked is what's the attacker's share path, right? So let's filter based on the victim IP address. Okay, so we have source from the victim request. So if we take a look at what we have on the attack vector, you can see that the victim, once a request enumeration printer driver was done to enumerate the list of printer driver, the victim IP address returned the path, of the device driver. So it is that same after the victim returned the path for the existing printer driver. So you can see that during the request call function for ROPC add printer, attacker shared assign a path where the malicious DLL file is hosted. So that is what the question is asking. So what we are going to do now is to look at, take a look at this part. So you can see 3 connect requests. You can see there's a request. You can see part where we have, this is the attacker's IP address, don't forget. So you can see a 3 connect requests is done from the victim machine to the, what's it called, the attacker's machine on .2, right? And look at the file that is being hosted on that part, right? So this is what we're going to do. let's take a look at other tools to see what is available. So on the brain, um, let's just check what is available on the brain. So just a minute. Okay. Okay, so we can see that we have different event type here. One of the things we're going to be looking at is, let's see, connection of files. So let's take a look at SMB, because the share file is going to be an SMB file. So we have an event type that is called SMB/file. So let's query for that, SMB/files, to see if the path is specified over there. So guys, you can see, okay. So guys, you can see that we have the path specified. You can see and look at the .dll file that is hosted on that path. So we can choose to click this and take a very good look at what we have. So I'm just trying. So I can see that our path is .2/share. So let's fix that to the question. //10.10.10.2, right, /share. Do we have to put that in brace? Yeah. Then I'm going to do this. Okay, guys, so that is the third one. Let's take a look at, to show you guys. You can see this is the path, this is the file that was shared. So SMB file open, guys. So if we take a look at to see the connection, to analyze, look at it. Once the three-way handshake is established, we can see that you can see that the victim machine, requests for to copy the malicious DLL file from the attacker's machine, right? So on that /share part, which is hosted on the SMB. So guys, this is how we're able to arrive at the answer. Okay, guys, let's go on to the next question. So we have the next one saying, what's the name of the malicious file? Okay, we already got that. So we are sure that the malicious file, the name of the malicious file is, you can see, is not so stealthy.dll. Why? Because that is the only DLL file that is hosted on that SMB shared drive. And like I said, the PrintNightmare vulnerability, most attacker would leverage on using a malicious DLL file, because it's going to be loaded in memory and it's going to be executed using run DLL 32.exe. So I'm just going to copy this guy and go back to the question page, and we're going to do this. See, should be able to arrive. So that is the file. You can also do a check and check other or other tools to double confirm. Right, but because that's the reason why I choose this, is because this is the only .dll file that was hosted on that share part. So what is the SHA-256 hash of the DLL file? So if we take a look at, go back to our tool, guys. So what the good thing to do is to do a search based on this file, since we now know our DLL file. So we're going to run a search. So I'm going to do, let's start with the file system. On the file system, so I'm just going to click on the file system. So to see if we have this file available. Okay, guys, you can see, okay, sorry, can clear up. This is the difference. So I'm just going to search for this. Okay, while we wait, let's go on to search on other tools. Okay, so we can come over here to search for this particular file, to search through our logs. So guys, you can see we're able to search through our logs for that particular file, and this is the result we have. Okay. Okay, guys, let's open the file, take a broader look at other details available for that file. Let's see what is available on the red line. Okay, so if you are going to reinitiate this, the red line is kind of easy. It's not responding. Okay, let's take a look at what we have here. Okay, guys, so look at the file. So guys, you can see we can from this log details, we can see this is the name of the file, and we can see the MD5 hash. We can also take a look at the SHA-1 hash. So to get what's it called, the SHA-256, we can right click and take it, do a virus total lookup, guys. So that would be like the easy way. We can also check on other threat platform like hybrid analysis, any.run. Okay, so come also to come up here to just go into virus total. Say okay. Virus. So that we can get the SHA-256 hash. So yeah, let's go on virus total, guys. Okay, so okay, it's taking a lot, some time. Okay, so guys, all we need to do is to search and look out for. Okay, I think we need to copy the hash files. Okay, so just a minute. Let me go back to copy the hash file. Okay, still loading in. So I'm just going to copy that the MD5 or the SHA-1 hash so that we can look up So we can either do a virus total lookup from here, but in order to be quick, I'm just going, since I have it open here, I'm just going to search for the MD5 hash. So you can see, guys, that particular hash is flagged by 39 security vendor. So when we take a look at the details, we can see that we have the SHA-1 and the SHA-256 hash, which is what is requested from us. So we're just going to go back to the question and answer accordingly. Let's see. Okay, guys. So we're able to establish the hash, the malicious DLL file hosted by the attacker. So the next question will be, what is the email address used for the safe sign SSL certificate in the traffic? Right. So we're looking for the email address used for the safe sign SSL certificate. So let us take a good way to look at this is to go back to our log and search for SSL traffic. So I'm just going to clear off these. So I'll wait for it to load. Yeah. Okay, guys. So we can see that we have SSL traffic. You can just filter for these. Okay, you guys can see we have SSL traffic. So let's take a look at what we have on the SSL traffic, right? And also on the connection event type. So I'm going to double click this, and also going to double click this. Take a look at what's happening on both sides. Yeah. Okay. So I can see some email address. Yeah. You can see that we have an email address, but so we can also see an SSL certificate validation field, self-signed certificate, email address is override at shield.mertz.net. So guys, this traffic. So let's take a look at self-sign. Okay, so we have a notice here. So if we take a look at the first one, which is the SSL event type, extend it to have a broader view. You can see that validation status is a self-signed certificate here. You can see the email address was specified here. Yes. Okay. You can also see the IP address is related to that of the attacker.2. So without wasting more time, you can take a look at, to double confirm, take a look at the connection requests that we have. We don't have any email specified at this point. I'm just going to close this and let us take a look at the notice alert we also received. You see, guys, you can see we're able to see the override. At shield, email address was also specified. Take a look at the logs. So you can see that the self-signed certificate validation failed. So, but the question is asking us for the email address. So good thing, let's copy this information. Right. So we're just going to do this. Yeah. So let's see. Hopefully this should be the answer. Okay, guys. So we're able to retrieve the email address used for the self-signed certificate just by looking through the logs, relating to that IP address. Okay, so what is the domain user used by the attacker to exploit vulnerability? So since we know that the attacker email address, IP address is .2, so we are going to go back to our log. So what is the domain user used by the attacker to exploit vulnerability? So if we go back to our log, guys, okay, yeah, our red line is still loading. So I'm just going to close up on these guys. So let us reset the search filter. So I'm just going to search up for the attacker's IP address. Okay, so we are looking for the domain username. So we are trying to look out through the logs relating to this attacker. Scroll through. So it's still loading. Okay, so what I wanted to do was to go through, take a look at the logs that we have. And just going to search through username. Okay, so we have another event type that is called MTLM. And we can see that it also relates to the IP address of what's it called? So we can do a proper search by saying and search by parts. You can see that we have this part here, and search by part to see where it is NTLM, right? Then we want to search only for the attacker's IP address. Let's see and say, okay, filter. So we can use this keyword filter and search for .2. Okay, we are given the same information. So we can see that we have, you can see .2 originating host. You can see on this IP address, this is the port, sorry. Then this is responding, originating, and to respond. On .4, which is that of the victim, you can see the username that we have, right? You can see the username we have over here, guys. So you can see we have jc.hammond. You can also see the domain name. So you can see the DNS computer name and the NetBIOS computer name. So from here, if we go back to review the question, it's asking us what is the domain user used by the attacker to exploit the vulnerability. So I think from what we can decipher from here, yeah. So if we take a look at so that we can copy the details. Okay. So on the red line, we also have, what's it called? We also have a data header for user. So let's take a look at what we have under users. You can see these are the list of users from the logs. You can see we have Jason Hanmon. Yeah. So if you notice, the other users are from the Active Directory. This is the Kerberos ticket granting tickets user account. The guest, the administrator user account. You can see this is also some accounts, local service accounts. So, but based on our analysis of what we've seen on the brain, I can say jason.hamon is the user domain username. So guys, what we're just going to do is to copy this out. All right, so we're going to also copy the domain name out. So we're going to specify this just like what we have from the red line. You can see this, show details, see. So let's go on to answer these questions. So guys, you can see we have, let me double confirm. Yeah, that's what we have. Okay, so I'm just gonna click on this. Okay, so that's also correct. So we're able to retrieve the domain user used by an attacker to exploit the vulnerability. So what is the exploit server host name? Guys, the exploit server host name. So the exploit server host name, let's take a look, go back to TPP. From the same logs that we have, you can see the exploit server host name. You can see the computer name. So the exploit server host name, this is the server that has been exploited. Take a look at. So you can see the originating host, which is the victim machine, which is the exploit server. This is the host name. So this should be the answer. Oh, sorry, I think I I inserted it in the wrong place. Okay, guys, so because if you check through with me, you'll notice that from the log, be able to see filter for the NTLM log files. You can see the originating host, which is .4, which is a victim machine, and that alone we're able to retrieve the host name, guys. So the next question is, what is the username created by the attacker for persistency? For persistency, guys. What's the username created by the attacker for persistency? Let's just take a look. Yeah. So okay, let's take a look at what we have on the red line. First of all, into filter for so if we take a look at the red line under the user section, we can see that a user was created called hacker. Guys, you can see that a user was created called hacker. If we go back to our brain, do we have any details for hacker? Okay, let us reset our search. So do we have any details called hacker? Okay. Okay, so we can, let's take a look at 10.10.2. On the brain, we have details called hacker. Let's take a look at what we have on the show details. Okay. You can see that the hacker username was also created on the domain controller, right? During the post-exploitation, after the user was able to escalate privilege, he was able to create a username called hacker. This is also, like the question said, to establish persistency, right? So guys, let's take a look at what we have on the event log. If we have any user on the event log that's called hacker. So if I have any events that was generated when a user was created, okay. So guys, you can see from the event that you can see a user account was created, guys. So from the event log, we can see that a hacker was created. Let's take a look at the show details. So event ID 4720, which means that this means what's it called? A new user was created. That's the for that is the event ID when a new user was created. That's generated when a new user was created. You can see the domain Bella Beer. You can see the account name. So this event is from, you can see Windows security blog. So of course, so this user was created. You can see the different users that we have. The user account was created, the user account was enabled, which is the hacker account. An attempt was made to reset the account password for hacker account. The user account was changed. You can see, so these are the major activities that we have from our log, security auditing log. So having said that, we can establish that the, the username is hacker. Okay, guys, so let's move on. Okay, so we have about 13 questions. What is the event ID for user creation in Windows? And when was the user being created? And when was the user being created? So you're told to look at red line again, the event ID and the timestamp when the user is created. So if we go back to red line, you can see, so user was created, we want to show details, you can see the event generated time, copy this out, you can store it on a notepad. Also, you can see the event ID that was generated for 720. So if we go on to check on what other details was asked, okay, year, month, okay. So event ID, okay. So we can do this. So we can go on to put the answer in the requested format. So guys, okay, inside these so when is the event ID for user creation in Windows? Then when was the user being created? When was the user being created? Okay, guys, that was correct. I think it was a format issue. So what process name is used to establish a shell connection between the attacker's machine and the Windows server? Right. What is the listening port on the attacker's machine? So guys, I think we're able to actually get these out. Um, so if you look at what was the process name used So let's go back on our log file. So under on red line, you can take a look at file system. No, sorry, the port. Person was asking for was the process name that was used to establish the SSL connection, and also what is listening port. So of course, we'll come on the port. So if we take a look at, we noticed earlier that we just have only a single established port. So run dll32.exe is the process name. You can see that it was established using port 49946. So we can click on these to show more details. So then we have the port. So we have the ports. So the next thing we are going to do is to so guys, we have the process name and the port. So don't forget, we're able to get these from the red line too. Okay. And these. Okay, let's take a look at it again. What's the process? What process is used to establish the shell connection between the attacker machine and the Windows server? Okay. If we take a look at red line again, I think that is the only okay. Okay, so I was using the what's it called? The local port. I think it should be the remote port. 443. 443. Okay, guys, this was also correct. This is correct. So we've been able to establish the process name and the shell ports, guys. So let's go on to reading the next question. I think so guys, for the question 12, we are given that the attacker used a famous post-exploitation framework to create the DLL file. So that was the malicious DLL file, and established a shell connection to the Windows server. What is the payload the attacker used? So if we take a look at the hints, they are given that the answer format will be like in this structure, right? So let's take a look at what we are told here. This might not look very obvious at first, but the framework is very famous and used widely by pen testers for post-exploitation. So at this point, my guess would be it's going to be MSF Venom, that's mostly used for creating, malicious, applications, malicious setup files that can be used for post-exploitation. So MSF Venom. There are also other payload out there, like power exploits, and the likes. Okay, so for the payload, the attacker used a self-signed certificate. Yeah, we knew that. Think about what protocol SSL certificate is associated, right, with, and there is a payload associated with the protocol in the framework. So the question is, what protocol SSL certificate is associated with? If we take a little deep dive to check on on our packet, we notice that the attacker made use of a self-signed certificate, just as we can see on the console, right? So what I did was to filter the log based on the SSL certificate and take a look at what we have. You can see that we have the victim IP address and also the attacker IP address. So if we take a look at, if we try and filter based on just the attacker IP address, where we have filter, then we can put the IP address .10.10.2. So we are going through this route basically to confirm the protocol, the pulse that was used during the for the self-signed certificate. So if we take a look at, we have about 7 records. So let's take a look at what we have under the notice. We can see, if I double click it, while it's loading, we can take a look at the record. We can see that we have an invalid server sat, right? We can also see that the attacker IP address .2 was trying to connect, respond via port 443, so which is an HTTPS port, right? So having seen that, this is giving us a hint that the payload, we have HTTPS within it. So because we have several payloads within the MSF Venom, we have payload for HTTP, and TCP, reverse TCP. So we want to be sure what we have. That's why we are going through this, trying to filter for specific log. So if we take a look at what we have, sorry, this is for the red line. Yeah, we're meant to look at the full details that we have on the brim. Yeah, yes, guys. So we can see that this is a field SSL certificate. And if we take a look at it, the TCP protocol on port 443. So look at the destination protocol, right? You can see the destination port, sorry, is on 44. The destination port is on 443, which means that it's HTTPS, protocol. Take a look at, let's see if we have other information when we scroll down. So this is what we are working with, guys. So we can now do a further search on Google to look out for specific payload, right? So what I did was to go query out list of payload on Google for MSF Venom to see. So we can see that we have Linux Meterpreter. So let's take a look at. So this is a window reverse TCP shell. So since the attacker leveraged port 443, so let's take a look at what we have for, if we can see that of HTTPS. Okay. Okay, guys. Okay, so we have in this list, we have window X 64 bits, interpreter reverse HTTP, guys. So I'm just gonna, so this for HTTP. If we scroll down, these are for Linux operating system. So I'm just gonna do that. So because HTTP will not leverage 443 to leverage 80/80. So let us do this and try and use this guy to see if come out with the best answer right here. So we need to close using open and closing brace. Okay, guys, thanks. So we are able to establish, this answer following the hints that we have. So we didn't use HTTP because HTTP will mean that the attacker is using port 80 for his self-signed certificate. But from what we gather within our log, the attacker actually was connecting on port 443, right? Not 80 or any other port. So that is why we specify HTTPS. So guys, let's go on to look at the last question. So we asked, the attacker left a text file for the user administrator. Can you find what the file name is? So if we take a look at the hints that was given, we're just told that it is within this format. So, and we should take a look at what we have on red line, guys. So let's take a look at what we have. So guys, let's navigate to red line and check out how we can spot out the file name that was dropped, by the attacker. So the first thing we'll do is to go on to red line, and so because we are looking for file name, we are going to base our search on the file system. Yeah, so just click on the file system. Right. So if once you click on the file system, we go on to the filter. Right. So initially, we have all the filter selected, during our search, so that we can have an overview of all the files, the DLL files, application files that are currently within the file system. But currently we want to filter and streamline our search just to specific files. So what we need to do is we're going to disable these, disable all the selected checks. Then we are going to enable just the document checks because it's a .tsc file, right? So, and we're also going to disable the red line because this red line contains a list of files that are not necessarily .txt. You can see that we have .bat file included and several DLL files. So I'm just going to disable the red line. So guys, you can see we just have 3 records from our filter, and we have a desktop.ini file. We have this is a folder. Then the only part where we have a TXT file is this. So guys, this is the file. So let's take a look at other details to confirm. Yeah, so you can see, like I said, is a .txt file, right? And you can see the parts stored on C drive. So guys, this is my hypothesis. Let's take a look at if it's correct. I'm not sure we have, let's take a look at other, what's it called, to double confirm if we can find this on Brain. So I'm just going to clear the search. And let's take a look at if we can search for this file. Double confirm. You see that we have no results on this file. So this is a very good use case to show that a particular tool is not just enough. It's very good to make use of different tools when analyzing. So let's take a look at let's fill the question. Hopefully we may be correct. Okay, guys, I think this is the last question, so it's definitely correct. So a key takeaway from this is that it's useful to use more than one tool when carrying out an analysis, because most of these tools have different logic, logic design and different rules for checking out logs, so it's just going to be helpful. But we've been able to complete majorly all the questions that we have for this challenge, right?